So, I'm guessing we all like looking at memes on the internet. What do all of these memes have in common? They're composed of pixels. Just like an atom is the smallest unit of matter, a pixel is the smallest unit of a digital image. Conceptually, it's a tiny dot on the screen containing one color. Just to make this easier to understand, so let's look at a 1-bit depth image. 1 bit really just means one binary value or two choices. So in this case, there are two color choices, black and white. This visual representation can also be represented with numbers. 0 is black and 1 is white. Computers behind the scenes take these numbers to assign each pixel a color value, resulting in a coherent image. However, we can get more shades between black and white if we want to. We just need more bits. If we have a 2-bit grayscale, that's 2 to the power of 2, or 4 shades, or 4 color choices. If we have a 3-bit grayscale, that's 8 shades, and so on. The point is, the more bits you have, the more tones or colors you have in your image. However, the more colors, the more memory or computer storage space you use up. Like if I were to ask you to remember over 256 different colors, or 8 bits, that would be overwhelming. In other words, if you have more bits, you can have more colors, but the more space you use up, then the less memes you can store. Or we can just cheat. We can seemingly have lots of colorful memes while using less bits by dithering. Let's switch to a different 1-bit depth image. In this image, the pixels are either completely black or completely white, so why does there seem to be some in between? There seems to be some gray, but we can only have completely black or completely white pixels. Let's look a little closer. Well, it turns out that up close, it is indeed just black and white pixels, but when looking farther away, our eyes perceive the combination of pixels in that area as gray. This concept, where we create the illusion of more colors with a limited color palette, is actually an image processing operation called dithering. It applies to color images as well. Take our original meme. It seems like there may be hundreds of colors in the image. However, it's only comprised of 16. I bet you didn't even notice. Here's the original. Just like in our previous 1-bit example, if we take a few colors and look at them further away, our eyes perceive the average of those values. There are so many different algorithms used to dither images. The one used for these is one of the most popular ones, Floyd-Steinberg, which is based on error dispersion. As you can see, humans can only process so many colors. We don't need every color when looking at the big picture, which helps when hardware has its limitations. Even modern-day printing uses dithering. Printers can only print a limited amount of dots per inch, and there are only 4 ink colors to choose from. For grayscale prints, only black ink is used, so dithering is used to get those gray tones. Even for color printing, dithering is utilized. The world is comprised of billions of colors, but machines don't have the capability of remembering, storing, and relaying all of them. Even now, dithering helps to generate good approximations of images, to the point where we don't even notice the difference.